Today, Telifox will be teaching you the second part series of Ubuntu security for servers. So let's begin. We're here at the official Ubuntu website and we're looking at the certificates. We are going to install and assign self-signed certifications. Now this is useful for securing your network devices that require encryption. So for example, you have your FTP server. If you want to make it secure, you want to add your security cryptographic certification. Or if you want to secure, for example, your internal website, you could use also self-signed certifications. So let's begin. The first step is to install openssl. Let's go ahead and do that. Sudo apt install openssl. Then we enter in the administrator password. Okay. Let's do sudo apt update and then sudo apt upgrade as well. Okay, and then let's do upgrade. Sudo apt upgrade. Click Y for yes, and let the upgrades install. So the first part of the process of creating a self-sign certification is to generate the key. We can generate the key with the following command. Sudo openssl genrsh, so that generates a key for the RSH type encryption, and you have -DES3, that's a type of encryption. You do out dash and then server.key, and you give the key bits of 2048. Go ahead and press enter. From here you need to assign a strong passphrase for the key. So we assign the pass key phrase now. Re-enter the pass phrase for the key. And then press enter. So now we have generated the keys. For the best security practice, it's good to have at least 8 characters for your passphrase. Minimum length is 4, but it's best to have 8. For me, I use about 12. It's also best to include numbers, punctuation, and not be a dictionary word. And the passphrase is also case sensitive, so just make note of that. So now that we have the keys created, we could basically shuffle the key names. Now that we have the key for the encryption, we want to go ahead and generate the CSR file. We can generate the CSR file by using the following command. Sudo openssl requirement -new -key server.key -out and server.csr. We want to press enter. So from here we create a password phrase for this key. So we enter in the password phrase that we created initially before. And then from here we need to add a country name, a 2-letter code. So for example, if we live in Australia, we would probably use AU. If we lived in Austria, it'd be probably AT or something like that. Since we live in the United States, we just click on YS for US and then press enter for the country name. the state or providence. So we just go ahead and give it a name. California. Locality. We will leave locality, actually we might have to add a city name. So let's go ahead and add, let's just do Let's just do LA. There you go. Company name. Alright. And unit name, organizational unit name. We will keep that blank. Wants the server fully qualified domain name, so that is Telifox Corp HQ.local. Email address, we don't have to enter that. Please enter in the following extra attributes to be set with your certifications. A challenge password. So we want to enter in a challenge password here. And optional company name, we will do Telifox Corp. And there you go, the certification is completely signed. You can now submit this CSR file to the CA for processing. The CA will use the CSR file and issue the certification. On the other hand, you can create self-signed certification using the CSR. So to create a self-signed, I will show you how to do that now. To create the self-signed certification, we type in the following. I want to clear the terminal, and we type in sudo openssl.x509 -require -days 365 in server CSR signkey, and then server.key -out server.crt. So once we have this command, and I'll leave this command in the description of the video, we should be able to assign and create self-signed certification. So we go ahead and enter that now. So as you can see, it's generating the private key. What it wants to do, it's asking us for the passphrase. So we just enter in the passphrase that we created for server.key. Okay, now you have the self-signed certification. Now what we want to do is install the certification. So we type in sudo cp for copy server.crt -etc or etc ssl certs. So before we do that, I do want to make sure we have that in our computer here. So etc, then ssl, let's go scroll down here. We do have SSL and we have the certs. Okay, that's good. So we go ahead and copy that. And then we do sudo cp for copy server key etc ssl private. And there you go. Now simply configure any applications with the ability to use public cryptography to use certification and keys. For example, Apache, HTTPS, or Dovecot can provide IMAPS. So you would just apply this self-signed certification to your application that you are running. An email server or a FTP server are two good examples. Alternatively, we can create our own certification authority. To do that, we need to enter in the following commands: sudo make drive etc ssl ca. This is going to make a drive in the etc SSL directory, and the folder is going to be titled CA. We do the same thing, sudo make drive, etc SSL, and new certs for new certifications. The CA needs a few additional files to operate. One, to keep track of the last serial number used by the CA. Each certification must have a unique serial number, and another file to record where certificates are used. So we type in the following to do that. We type in sudo sh-c in quotations echo in singular quotations 01 close, and let's see. So I do believe this is going to make a link to a specific serial file. So we type in etc SSL CA serial, close the double quotations, and then you press enter. Then from here we type in sudo touch etc SSL CA index.txt. The third file is a CA configuration file. Though not strictly necessary, it is convenient when using multiple certifications. So we want to go ahead and go into the edit sudo nano etc SSL open ssl.cnf for config. And as you can see in this file, there's a bunch of different configuration settings. Okay, so the following changes were made to directory right here. This entry, we added etc-ssl. For database, we added ca-index.txt. For certificates, we added certs-ca-cert.pem. For serial, we added ca-serial. And then last but not least, for private key, we added /private and then ca-key.pem. After the changes were made, we go ahead and save with Control X, Y to accept the changes, and then press enter. Now we want to create the self-signed root certification. We type in the following: sudo openssl require .new -x509 -extension, and the full command will be in the description below, so I'll go ahead and just type it up without having to tell exactly the command word for word. ca-key.pem -out cert.pem -days for I think how long until it expires, and then we do 3650 and then press enter. Now we will be asked to enter the details about the certification, so go ahead and enter in the password phrase for this specific key and enter in and verify the key one more time. Now it's going to ask you all of the information that it did for the other certification, so we just enter in the defaults. Okay, now that's complete, we just need to install the root certification and key. So we do that by typing sudo move ca-key.pem to the etc. So we're moving it to the etc ssl-private folder. So sudo move ca-key.pem etc ssl private, press enter, and then we do the same thing. So we want to move the ca-cert.pem to the following folder. So we do sudo make ca-cert server.pem etc SSL certs. And there you go. Now you are ready to start signing certifications. The first item needed in a certification signing request is to generate a certification signing request. Once you have a CSR, enter in the following to generate a certification signed by the CA. So we do that by typing in the following: sudo openssl.cnf server csr-config etc ssl openssl.cnf. So it's a configuration file. So I'm just going to double check this command and make sure it's correct, and then press enter. And then we enter in the password phrase that we created for the cakey.pem file. And there you go, you have your signed certification. So after you enter in the password of the CA key, you will be prompted to sign the certification, and again to commit the new certification changes. You should now see a somewhat large amount of output related to your certification creation. There should now be a new file in your etc SSL new certs. So we can double check that. Let's go ahead and go over here, new certs, and let's see if the file is there. So let's go ahead and create one more CSR signing certification request. So we do openssl genrsa, and I will leave the command in the description here. Key 248. Okay, so before we sign the certification, I did have to comment out the random file, which is a random number generator according to my research. So after that, we enter in the following command one more time: sudo openssl-ca-in server.csr-config, and then etc ssl openssl.cnf. And then we enter in the password phrase. And as you can see, it's asking us, the certification is going to be certified until November 28th of 2022. And that's 365 days. Do you want to sign the certification? So you type in Y. 1 out of 1 certification request certified. Press Y. And there you go. So you would just copy this into the program that you're using. So this is complete. Now what we want to do is copy this information that we have here. Most likely this will be blurred out in the video, but copying the begin and end certification cryptography, and then pasting it inside of your email server, FTP server, and then you should be set. So let's do one more thing. Under new certs, as you can see, you have the 0.1 file. So if you create subsequent certifications, you will have more certifications signed here. So let's just do one more, I guess, for the case scenario. So we do the same command that we did before. Enter in one more time. and it looks like the certification is already valid. So if you had multiple certifications, you would just re-sign them here. Finally, you want to copy the new certification to the host that needs it. Configure the appropriate application to use it. The default location to install certifications is inside etc SSL certs. This enables multiple services to use the same certification without overly complicating the file permissions. For applications that can be configured to use a CA certification, you should also copy the etc SSL certs CA PIM to the file certs directory on the server. So we do that now. So what we do is we do sudo cp for copy the following path name. So we want to copy CA certs in the following area. So that's etc SSL certs CA certs.pem, and we're copying that to etc SSL certs. Okay, so let's just do, oh, I forgot the T, that's why. There we go. Okay, so the cert is already in the correct location. That's a good sign. And basically we are all set. The CA certification is already inside of the proper folder. Now from here, all the applications on this specific server are going to be using this signed, self-signed CA certification, and it will make sure that the cryptography is nice and secure for the system. So that's how to implement certifications and self-signed certifications and CA certifications on your server. What we could do now is we can install the CAPM form certification into the trust store. So to do that, we type in sudo apt-get install-y CA certification. Next, we type in sudo copy local CA cert to the local share CA certification. So we do sudo copy, we'll do 01.pem, and then user local share CA certificates. Right, so we just give it a actual directory path name. It said that it couldn't find it, so we go ahead and direct that to where that path is. And there you go. So we copied that new certification that we self-signed and put on a CA base, and then we copied it to that location to the share CA certifications. So now what we do is sudo update CA certificates. Gotta retype it. There you go. So 0 added, 0 removed, done, running hooks, and let's see. It looks like it is complete. At this point, you can use Ubuntu's tools like curl and wget to connect to local sites. So, how do you organize the form? A PEM formatted certification is human readable in base 64 format. Starts with lines begin certification. If you see these lines, then use the instructions for PEM. Otherwise, it's for the DER certification. So that was just based off the roadmap that we're using. Alright, that's everything involving security measures to secure and harden a system based on the Ubuntu OS. If you enjoyed this video, please like, And don't hesitate to contact Telifox for all your consulting needs. You have a good afternoon.